everyone! Today I'm going to talk about template files in Rhinoceros. Okay, so when you open Rhinoceros to start a new file, you'll probably see a splash screen like this. From here, you select a template file to get started. Now, there are a few important things you need to pay attention to, and I'll walk you through them. First up are the units. You need to make sure you select the unit you'll be working with, whether it's centimeters, feet, or inches, as you can see here. But wait, there's more. For example, you have large objects, centimeters, and also small objects, centimeters. You might be wondering which one you should use, right? Let's look at the large objects, centimeters template. If I move my cursor, this window will disappear, so I'll keep it still. See this yellow area on the right? It shows the units, the absolute tolerance, that means how precise we need to be, and the display format. The unit is centimeters, but the next part, the absolute tolerance, is really important. Right now, it's set to 0.01, which means 0.01 centimeters. When you're trying to join two objects, if the gap between them is less than 0.01 centimeters, Rhinoceros considers them to be touching and will join them. It's all about precision. See? Now, if we look at small objects, centimeters, you'll see the tolerance is 0.001. There's an extra zero. This means the program won't consider objects to be joined unless they are much closer together. It's a higher level of precision. The smaller the number, the higher the precision you get. So you might think, well, higher precision is always better, and just pick the smallest value. But you should always choose the template that matches the level of precision your specific project actually needs. The higher the precision, meaning the smaller this number is, the more data the computer has to handle. This makes your file size bigger and can make editing really slow and clunky. If you don't actually need that level of precision, but you used the 0.001 template anyway, you might run into problems. For instance, trying to close a tiny hole can become a huge pain, and you'll just end up wasting unnecessary time. So you should always choose a tolerance that matches your project. Ready? Since I specialize in architecture, I recommend using the Large Objects template for architectural projects. Even if you plan to fabricate your model, it's questionable whether manufacturing processes can even achieve a precision of 0.001. So for most projects, starting with a tolerance of 0.01 and moving forward from there is probably the best way to go. Okay, so how do you make your own template file? First, you can choose your units here. Maybe you use microinches, mils, or even picometers. You can change the units and tolerance right here. Once you're done setting it up, just click Save as Template, and it will be saved and show up in that list we saw earlier. Now, here's something you absolutely have to be careful about: the units and the absolute tolerance. Never, ever change these settings in the middle of modeling. Got it? If you need to change them, do it right after you open a brand new empty file before you've created any geometry. if you don't, you'll end up with objects that have different tolerances mixed together in the same file. This makes your data really unstable, and you might even get to a point where you can't open the file anymore. So please be very careful about this. Why bother creating a template file? Well, if you're just working by yourself, it might be fine. But when you start managing a project as a team, it's much better to have a template with the project name and the correct units and tolerances already set. This really helps reduce human error. It's easy for one person to be working in centimeters, another in millimeters, and someone else using the small objects template. These kinds of mix-ups can definitely happen. To prevent this, it's a great idea to use a standardized template to make sure everyone is building shapes the same way. Okay. That's all for our look at template files.